Okay, this is section 2, and like I said today in class, we're going to get into variation. Variation, what we're talking about is the same as what you think about in your day-to-day life. You know, variation is the difference between things, how much things change, and that's what we're talking about here. It's just that we're talking about it with numbers, and usually not always, but when we get into like variance and standard deviation, we are talking about how much do these numbers vary from the mean. So we're talking about how much do they vary from the average, okay? So here are a few ways that we can measure variability. The range, which is how much change is there, how much difference is there from the highest to the lowest. It's one of the most basic ones, but it is one way. Variance, like I talked about in class, which we really don't have an understanding of what it is yet. And standard deviation, which again, we really don't have an understanding of what it is in great detail. For right now, just understand that it's some kind of measurement that tells us how much all the data changes according to each other. Okay, so how much, are all the numbers pretty close together, or there are some that are really high, some that are really low? Okay, you're going to get a value, and you won't understand yet if 1 is a lot or 10 is a lot, or, that's fine. And just get past that, just understand how to calculate it right now. We also have coefficient of variation, Chebyshev's theorem. I'm not positive if we're going to, how deep into that theorem we're going to get. It'll kind of depend on time. And the empirical rule. So those are for another day. We're going to focus on range, variance, and standard deviation today. The range, like we said, you all know that the range is the highest minus the lowest. Okay? Pretty simple formula. Here we go. We have that example that we talked about today in class with the 2 different brands of paint. And what we're going to do is we're going to get into how we calculate variance and standard deviation. Okay. In order to get the variance and standard deviation, we need to calculate the mean for both of them. We talked about that in class today as well, that the mean for both of them was 35. But as you see here, the range is 50 for brand A and 20 for brand B. And, which one would you rather have? The one that can be anywhere up to 60 down to 10, or the one that's a little bit more consistent? And I can't answer that. Most people, I think, would pick brand B just because you're going to get more of a consistent product. But maybe some people think, hey, I could get lucky and get that can with 60 in it. Okay, variance. The definition for variance really doesn't elaborate or give us any more detail on what it actually is. So I'm just going to stick with the definition from the book. It's the average of the squares of the distance each value is from the mean. So it's basically saying how far is each value from the mean, square it, and find the average of that. Standard deviation is just the square root of the variance. We will show you later on how to take that standard deviation number and translate it into something that will tell you how spread out your data is. Why do we use it? We want to figure out how spread out is our data. Is everything pretty close, or things really high, really low, a little bit in between? It's basically the same thing, the consistency of it. For these paint manufacturers, they want a consistent product. Nobody's going to get on a commercial and say, hey, our product varies from one car to the next, or from one can of paint to the next. You never know what you're going to get with our paint. No company wants to do that. Companies want to get on and say, we have a very consistent product. You know what you're going to get when you buy our product. And consumers want that. A lot of consumers want that too. You don't want to, think about your food. Nobody's going to be selling milk that says, hey, you don't know if you're going to get a rotten jug of milk or something that's super, super fresh. No, you want to know that, hey, this is milk that's going to taste good. This is how it's going to taste. It's going to taste the same every time. As long as I buy the same brand, I want consistency. I'm going to skip this part because we're not going to be going into that today or that. So here are your formulas for population. Remember, the formula for population and sample is the exact same, except with a sample, you're going to use n minus 1 down here. So population variance is sigma squared equals the sum or sigma of x minus mu squareds divided by the number of items in the population. And then your standard deviation is the exact same formula, just the square root of it. So here's an example. You do not have to use a table for this. I highly suggest it. I think it's much easier for you to do the calculations. I think you will minimize your mistakes by using a table, but it's not a necessity. So for this, we already figured out that our average was 35. So we're going to put 35 in for each one here. And then you're just following the formula. You're taking all your x minus mu's. And that comes from right here. So we want to take all of our x minus mu's, like we did, square them all, and we get these numbers. Add them up. The reason we add them all up is because that's what goes up top here. These are all of your x minus mu's squared. Sigma means add them all up. So that's 1750. N, there's 6 of them. 1, 2, 3, 4, 5, 6. Do that, you get 291.7. Again, the rounding rule. Always round to one more decimal place than our data is in. Our data is all whole numbers, so we go to the nearest tenth. Standard deviation is just taking the square root of this, which is 17.1. So your variance is 291.7, standard deviation of 17.1. Here are the formulas for your sample. Like I said, exact same. Instead of using sigma, they use s squared and s. And instead of mu, we use x bar. Other than that, the same except for n minus 1. Here's an example. Here are all of our x's. This is from page 129. These are our x's. This is the amount of auto sales. All these numbers were in millions for 6 different years from specific European auto company. Sorry, I don't think it was a specific one. I think it was all European auto sales. So we got 11.2, 11.9, 12, 12.8, 13.4, and 14.3. I averaged them out. I'm not showing you that right here, but I averaged them out, and you got 12.6. So we take x minus our x bar. For all of these, sorry that for some reason my x bar is not showing up very well. It looks like an x bar there. Just a little bit. My x bars are not showing up. This should be an x bar here and an x bar there. Let me see if I can throw that in. Yeah, it's not. Just know my pen is acting up. Know that this is an x bar, this is an x bar. So we take x minus our x bars, 11.2 minus 12.6, we get negative 1.4. We do that for all of them. Then we take these numbers and we square them. And this is what we get. So here's our formula. Right here, we already did this part right here. So sigma means add up all these numbers right here. when you do, double check, make sure you're getting the same answer I am. You get 6.38. And you divide that by 6 minus 1 because there are 6 numbers. That gives you 5. 6.38 divided by 5 gives us 1.28. So there is your sample variance. To find your standard deviation, simply take the square root of both sides. Leaves us with S. Square root of 1.28 is 1.13. So that's your long version. And I don't even know if you can consider it longer, but it's considered, I guess, a standard version. It has to be the standard version because this is what they call a shortcut formula. This will give you the exact same thing as this. And it's more or less a personal preference some of the times. Sometimes I'm going to tell you you have to do it this way, you have to do it that way. But as far as mathematically speaking, you will get the same answer no matter what. So I'll give you a second. You need to pause the screen. Go ahead. That's your sample variance. This is your sample standard deviation. Here we go. These in action. So again, remember the difference is we do not have to have our X bar. We do not have to find our mean in these, which is nice. So here are all of our X's again. What you have to do is you have to find all of your X squareds. That's these right here. After that, you are just putting your information into the formula. So we have to add up all of our X squareds. So if I add all these up right here, that comes out to be 958.94. The summation of all of our X's, if we add up all of these right here, we get 75.6. We need to square that number, which gives us 5,715.36. Over here, we had to take 6 times this number to get 5753.64. Down on the bottom, n is 6, and minus 1 is 5, so 6 times 5 gives us 30. We subtract these two numbers, we divide by 30, and we get the same number as we did on the previous one, 1.28. Take the square root of that, and of course you're going to get the same number again. So you see both formulas, same answer. All right, that is your standard deviation, your variance, and your range. We will see you tomorrow in class.